Yeah, I'm Abhishek, co-founder of KoalaLab, and today I'm going to talk about building secure and minimal base container images. So we had, as Ram mentioned, quite a few talks regarding like building guardrails or building like using scanners or S-bombs to like prevent yourself from vulnerabilities. I am going to focus more on building on strong foundation of secure and minimal base container images. Yeah, so let's dive in. So these will be the takeaways from this talk. Like first of all, we will get to know about the challenges that are there in the existing off-the-shelf container images. Then, like in those images, there is a lot of bloat. What that is, we will dive into that. But where is it coming from? And like then there are approaches around like creating your container images from scratch. What challenges will you face around that? And then finally, I'm going to present few of my ideas around creating a container-focused Linux distro that will be like that is to enable people to like build their own minimal container images and that won't have any of the problems that current off-the-shelf images have. So as we know, the software development today is containerized, and organizations run hundreds of hundreds of containers, be it a language runtime or a cloud native stack like Nginx, or it can be a database. So these container images, the off-the-shelf container images that I'm talking about, are built on built using a VM-focused distro, and that is why we say that this transition from VM era to containerization. This is one of the key reasons for all the bloat that we see. Like if you go and pick a off-the-shelf image from Docker Hub, it will have so many packages that you normally see on your, let's say you run a Linux distro on your own machine, you will see it there, but they have creeped into your containers as well, which was not meant to be, because VMs have a very complex life cycle. They serve many different purposes. You are running a full OS over there. But containers were intended to run a process in isolation, right? You want to just put some, you can say checks or guardrails in place for a process and run it. That's what a container is. So let's quickly take a glance at this Python 3.9.21 Slim image from Docker Hub. It has 115 packages, but actually to run a Python, let's say based on just taking from off-the-shelf Debian packages, you just need 28. So these packages, like there are 80 odd packages which are not at all needed there, but they are still there. Why? We will deep dive into that. So the bloat that I'm referring to, obviously it increases the attack surface, and in security, it's all about like covering your bases. So like reducing the attack surface is the first approach that comes to mind. So keeping us image small not only reduces the attack surface, like it will also reduce your SBOM, and it means like you will be vulnerable to less CVs and will require patching less frequently, which like in itself like increases the developer productivity by a lot. Many people do argue that many of those packages are not reachable into that container, so like they can stay there. But that presents a even stronger case to get rid of them. If they are not reachable, they are not going to be used. So then just remove them. It will like make your life or the whole CV management process hassle-free. We have seen some good work from ChainGuard or Iron Bank images or Alpine images, and the results have been great. And apart from this, like the minimal container images also have like performance advantages as well. Like they have a smaller memory footprint. The boot time for the containers are faster. They take less storage space. So by now, I guess I have convinced you guys to like debloat your containers, right? Have I? Okay. If you want to debloat, first you need to know where this bloat is coming from. So let's see. So when you look at, let's say, distro like a Debian or Ubuntu, like there are certain packages marked as essential. These were marked as essential in the package universe, keeping into mind the complex VM life cycles. Like you wanted to have a, let's say, a CLI to run, you want bash or dash, something like that. You want, let's say, Python into that. So these packages were kept like with that in mind. But as I said, a container, like it uses the kernel from the host machine. It's a simple process ran in isolation. So even a self-contained binary, if you put inside an empty file system, that is a good enough container. Like a Go container is that only. Like you put a Go binary and you run it. So it doesn't need all that. So no package is essential in context of a container. Then comes the there are this installation script. If you inspect a package, a Debian package, for example, there will be installation script like the pre-post installation, pre-post RM packages or triggers. Those scripts are like while packaging these Debian packages, those packages have runtime requirements. Like developers assume that there will be a Perl, let's say, already available on the system, or there will be certain packages already available on the system, and they use those runtimes to package. As a result, the whole universe of packages evolved to be such that just to install a simple package, you will need something that is not at all required at the runtime. A classic example is like, let's say you want to install dpkg. Now, dpkg to maintain the VM lifecycle have something to do with systemd helpers that will like schedule some tasks over there. And that helper is like invoked using this deb systemd helper. And this is written in Perl. So just to install dpkg, you need Perl, which is not at all required over there. And the last is the package management stack itself, right? So in the package management, like the APT requires like 59 odd packages, just like direct dependencies in the dependency tree. Even after these, like if you like install APT with this 59 packages, it will complain about things like coreutils or diffutils or APT utils at the runtime. Like similarly, like part of the APT tooling is in Perl, and like Perl itself requires like 13 odd packages to be installed just to run. So as you can see, like we are starting from 60 odd packages, like which are not at all required at the runtime. So one other solution that people have to this is like skip all package management, everything, and just create images from scratch. So let's see what's the issue with that. So number one issue that you will run into is like from scratch images don't play well with scanners. Like if you are like let's say compiling something, putting it inside a file system and creating your own Docker image from scratch, you will end up like not having the appropriate metadata that will be identified by the scanners. And scanners also rely on the security advisory like published by the distros to like identify the which exact version you have installed. I will demonstrate this. So here we can see there is a Docker file that I have written. In this, I'm taking a Python image that we have published, and from that, I'm just removing these two metadata files, dpkg info and dpkg status. So if you remove that, now we have two Dockers. We will run gripe on both and see the results. So if you run gripe on the original image, you will see that there are no vulnerabilities. There are 28 packages and 1176 metadata files in it. What happened with the stripped version? So in this gripe is identify only 14 packages. So now my SBOM has shrinked. And as I can see now, I have two vulnerabilities as well. Whereas the runtime or the binary in both the packages or both the Docker images are exactly the same. Why is it happening? Because the first one is a patched version of Python published by a distro. And with that, the distro also publishes a security advisory that this particular CV has been addressed in this version. But when you strip that, the container of that metadata, the scanner will only identify the binary. And in that binary, in the Python's upstream, that binary has this CV. So the container or the scanner will say that you have a CV. which actually you don't have. And second is the complexity. Like it's not easy to create a from scratch image, especially when you have multiple runtimes involved. And the options available for like off the shelf for from scratch images are also limited. So yeah, so with all this in mind, we did some ideation into like what should be the solution. So that's when we thought of a container-focused Linux distro, like which has a lean and simplified package management and like the whole package universe like repackaged so that the installation script bloat or other bloats that we talked about can be reduced or can be got rid of. So, so when I talk about, let's say, a package, lean package management or simplified, so what are the inspiration for that? So first, we can simply build something in Go which is very small and will contain binary, won't fetch so many dependencies. That's pretty straightforward. But the other is like the containers have a very simple life cycle with regards to packages. You don't need to ever update a package in a container. If you want to go to the next version, you will build the container again and have the new version in that. Similarly, like you never need to remove a package. You want to get rid of a package, you remove it and then again build a container. So the package management for a container will never need to worry about what exists in the container or any of the, let's say, backward compatibility or upgradation related issues, because it will always get a clean slate. Like you have the file system without that package and you are putting into that package. That simplifies things a lot. Like if you ever inspect any of the packages like that are like they are maintaining backward compatibility to like many versions back the chain, and the pre-post installation or the setup is insane. Next is like using the same insight, we can like simplify the pre or post installation scripts of all the packages a lot. As I said, no, always getting a clean slate has a lot of advantages and you can leverage that a lot. Another thing is like a container focused distro should always keep the packages up to date. A VM focused distro has many packages and their dependencies which are like pretty interlinked. So updating a package, let's say in any of the release of the distro, becomes cumbersome. What I mean by that is, let's say you have some library that is dynamically linked, and if you update that, you need to make sure all the packages that are part of my current release are like up to date or compatible with that. But in containers, it's my choice. Like I will have very few select packages installed in that. So that goes away. And next is like the last thing that we need to keep is have a better cloud native coverage, because containers ultimately will be deployed in cloud native solutions on Kubernetes. And there we want to cover each and every package. Like a distro today won't be like giving you packages for like what actually is needed on the cloud native environment, but will be giving you like more around package management or uh, sorry, not package management, running your own machine or running a VM, things like that. So like, that's it from my side. Thank you.